Okay, now in statistics, many times we need to figure out what the probability of a given score value is. In other words, what is the likelihood that a given score or a mean value of a population will occur by chance alone? This is a question that is very, very key in statistics, in calculating statistical tests. So we're going to return now to the normal distribution, which you saw earlier, and talk about a new concept associated with the normal distribution called the area under the curve. Okay, now I'm sure you remember a few of the characteristics of the normal distribution. I've drawn a normal distribution here by hand. The normal distribution, of course, is symmetrical, meaning that's exactly the same on the right side and the left side. The normal distribution, when it's drawn also, if it's drawn correctly, the tails never touch the x-axis. This is because this is a theoretical distribution, right? And the tails actually go off into infinity. All right, now you remember that we use z-scores to measure the normal distribution, and z-scores indicate fixed and symmetrical segments of the normal distribution, right? So it turns out, and this is the new piece of information for you, it turns out that the area under the curve, that is this segment plus this segment plus this, and this, all of those areas under the curve, if you add them up, equal 1.0. Very interesting. Now this is very helpful because this means that each z-score is associated with a specific segment, a specific fixed predictable segment of the area under the curve, right? And these are the areas under the curve that are fixed and symmetrical that are associated with each of these z-scores. Now this is very, very valuable for determining the proportion associated with a score, a single score, or a span of scores. You can also determine not only the proportion of the population that will obtain any given span of scores or a specific score, but you can also determine the probability of obtaining a particular span of scores or a specific score, and also the percentage of the population that will obtain a given score or a span of scores. So here are the numbers. Now notice that 0.3413 is the proportion associated with obtaining a score between 0 and 1.0 standard deviation above the mean. And 0.3413 is also associated, is the proportion associated with obtaining a score at the mean, or a z-score between the mean and a z-score of negative 1.0, right? So if you want to know what proportion of the population is likely to achieve a z-score between minus 1.0 and plus 1.0, you add together these two segment values, right? So it's 0.3413 plus 0.3413, and this gives you 6826. So what this tells us is that for a sample of scores that is normally distributed, 0.6826 is the probability that any one individual will achieve a score between negative 1.0 and positive 1.0 z-score, right? It's also the proportion of the population that will achieve a z-score between negative 1.0 and positive 1.0. It's also the percentage of the population that will achieve a z-score between negative 1.0 and positive 1.0 z-score. In other words, 68.26% of the population will achieve a z-score between negative 1.0 and positive 1.0. All right?